Hey, it's Todd with The Stop Shop. We just got in a physical sample from one of our customers that manufactures lawn mowing equipment, and they've asked us to reproduce this tube and make a run of them for them. So I thought today we'd take you through the process of reverse engineering a physical sample from one of our customers. We can do this. It's not quite as common as just having a print come over to us that we work off of to make parts, but sometimes this is what you get, and we want to show you how it's done. So the first thing we want to do with this particular tube is get it up on our fixtures and ready to be measured with our articulating measuring arm. We pull this out and we start measuring the straight sections throughout the tube. We'll continue this process all the way through to the end, which we're not going to actually bring you through on since we've actually pre-measured this tube, but wanted to show you what the process looks like. So once we've gone through, taken all these measurements, the software takes the tangent points between those straight sections and gives us coordinates to send over to our tube bender and reproduce this part. We'll bring you in and show you what these coordinates look like. Not only does it tell us our length, rotation, and angle statistics for the bender, it also will compensate for things like spring back and elongation, which are things we have to account for in tube bending. Spring back is simply when you bend any particular material of tube, you're going to have some amount that it springs back towards its original position. So if you make a bend to 90 degrees, certain materials might spring back to 85, others maybe to 87. So because we've worked with 3/16 stainless steel tubing before, we know exactly how this tube is going to react and spring back, and we can compensate for that within our software before we even make our first tube. So we're not busy making corrections on and on again after the fact. This also gives us the developed length for our tube, so we know how long to cut it ahead of time before we make that first part. All right, we've taken our pre-cut length that we got from measuring the tube on the measuring arm. We went over, cut one piece, and what we like to do sometimes is pre-flare the tube, put the end form on it before we even bend it. So that's what we're going to do here. This particular tube gets a double inverted flare per SAE J533. We'll show you what that looks like here on our flaring machine. We deburred the tube ahead of time, so we're ready to put a nice clean end into the machine. Get it ready. We get a nice, clean, inverted double flare. All right, we've got our pre-cut, pre-flared tube loaded in the machine and ready to bend. So we'll get started. Now we've got our tube here that's just come off. We'll take the original we measured and make a check to see how it matches up. As you can see, we've got a tube that appears by the eye to be a dead-on match. Of course, we're not going to take that. We're going to go take it back over to the measuring arm. And what we'll do is measure the tube we just made to make sure that it matches within the tolerances to the original part that we measured. After that, we'll go ahead and make our run of this part, add the end form to the opposite end, and have it ready for the customer. Thanks for watching today.